Okay, this is 2005, number 2, and it is a calculator open. And you definitely need your calculator to do this. So looking at the problem, we have RFT, which is removing sand, and SOT, which is adding sand to the beach between time 0 hours and 6 hours. And originally, it's really important to know that 2,500 cubic yards is how much sand we start with. So, letter A, how much sand will the tide remove from the beach during the 6-hour period? Indicate units of measure. So all of this problem is asking is how much sand will be left on the beach with just using RFT from 0 to 6 hours. So all you have to do is set up an integral from 0 to 6 of RFT dt. And if you plug this in your calculator, you get an answer of 31.816 yards cubed. And you know that it's yards cubed because your original function, R of t, is in cubic yards per hour. And so when you're solving this equation, when you plug your 0 and your 6 back into your equation, because you start with yards cubed per hour, and when you plug in your hours, when you solve the integral out, your hours will cancel. So you're left with yards cubed. Okay, and now on to B. Write an expression for y of t, the total number of cubic yards of sand on the beach at time t. Y of t is a function that shows the entire sand. So we have to use R of t and S of t. First of all, we start out with 2,500 cubic yards per on the beach. So y of t, and then you have to add the R of t minus S of t, or S of t minus R of t. So we have an integral from 0 to 6 of, oh, sorry, I take that back. We don't know how long we're going to. We just know we're going to a t time. And we have total number of sand added, which is S minus R. Now, normally we'd use S of t and R of t, but we can't because our interval has a t. So instead we have to use an x. So we have x of x minus R of x. And this is all dx, not t. And that is all you have to write for B. Okay, now for C, it asked us, find the rate at which the total amount of sand on the beach is changing at time t equals 4. But we already figured out from B that the total amount of sand is determined by the use of the equation y of t. So it wants us to find when it's changing, though. So that means we have to use the derivative of y. So y prime of t equals, when you take the derivative of an integral, it's just what's inside the integrand, which is just what is inside the integral. So now we just have S of t minus R of t. And it wants us to find at the hour 4. So all you have to do is plug in the 4. And I don't know why I wrote this up here. It should be an R of t. Okay, and you can just plug this really quickly in your calculator, and you get an answer of negative 1.909 yards cubed per hour. And that's that solution. And now D is asking us for 0 to 6, what time is t is the amount of sand on the beach a minimum? What is the minimum value? Justify your answer. Okay, So in order to do this, we need to set the derivative equal to 0. And to do that, when you set it equal to 0, it's the same thing, the derivative, same one that we used up here. So now we have y of t equals s of t minus r of t. And if you want to, you can solve it like this. Just solve for the intersection in your calculator, which is what I did, because it's a lot easier than the other way. And you get t equals 5.118 hours. But we're not done. We still need to check the sign to make sure, to see if it's a negative or a minimum or a maximum. So when you plug it in, 5.118, numbers greater than 5.118 are positive. Numbers less than that are negative. So because it's moving from negative to positive, means it is a relative minimum. But we're not done yet. It still asks us for the value of the relative minimum, so we need to plug it back in the y of value, y of t. So y of 5.118. I didn't really use 5.118. I used, that's the approximation. I stored the value in my calculator. So y of 5.118 equals 2,492.369. 369 yards cubed. And then explanation, the relative minimum is 2,492.369 yards cubed when t is approximately 5.118 hours. This is because the sign of y of t, y prime of t, changes from negative to positive at the point t equals 5.118. And now you're done.